Warm greetings, my dear students. So now the topic comes to this mole and mass relationships. You must know the significance of balanced chemical equation. Okay, this is very important. A balanced chemical equation tells us the number of atoms and molecules taking part in the reaction. Okay, and the corresponding masses in atomic mass unit. These and all it will explain. And the number of moles taking part in the reaction with the corresponding masses in grams or in other convenient units. I will explain you right now. So atoms, molecules, moles, and grams. What are all the relationship between all these things? As well as the volumetric analysis also. That is the relationship between the volume of the reactants and the products. If all of them are in the gaseous state, everything we are going to see further. First, we'll see mole and mass relationships. Okay, let us consider chemical reaction. What is it actually? So this reaction is between nitrogen and hydrogen. So if one molecule, you know what is a molecule, right? If it is an atom, if two or more atom combines, atom is tiny indivisible particle of matter, right? So and then if two atoms or more atoms combine to form, that is a molecule. Got it? So since this nitrogen is a diatomic, it is a molecule. So one molecule. So here it is only one molecule of nitrogen. Here it is three molecule of hydrogen. Okay. And then here it is two molecule of ammonia. NH3 is ammonia. Got it? So this is the balanced chemical equation, chemical reaction. You can able to see. Okay. There are two nitrogen and six hydrogen. In the right side also two nitrogen and six hydrogen, right? So it is balanced, okay? So we may multiply. Suppose if you want to multiply, this is for example, I can explain you. My son asked a very interesting question. So what is this molecule and all? I will explain you with this. See, for example, this is some cup of I can say it is an ammonia. Okay, here it contains an ammonia. In this cup, here it contains lot of nitrogen atoms or nitrogen molecule and hydrogen molecule. Right. We didn't know how much nitrogen molecule, how much hydrogen molecule is there to produce this much of ammonia. Okay, so suppose if scientists want to perform an experiment, definitely they need some volume, some quantity must be there. So we are assuming, or the scientists are assuming that, okay, they have taken out of it one molecule of nitrogen. For an example, we couldn't take literally one molecule of nitrogen with three molecule of hydrogen. Okay, inside this. Okay, it forms two molecule of ammonia. Like that, so many nitrogen is there, so many hydrogen is there. N number of nitrogen and N number of hydrogen to fill this. Okay, but what is the proportion? 1:3. There are nitrogen and hydrogen in this cup, but the proportion is 1 nitrogen is to 3 hydrogen. Okay, so this is the proportion to make ammonia, 1:3. Say, for example, you can relate always kitchen things, kitchen ingredients, kitchen baking, cooking, all are chemical reaction, right? For baking, you know how the ratio will be. You have to take the flour and then baking powder and then the remaining sugar. Everything should be in the proper ratio. Otherwise, it won't produce a cake. Got it? So same way, ammonia should contain 1:3 ratio of nitrogen and hydrogen. But we don't know how much it contains right up. So that we are going to connect it with the mole right now. So do listen. So if you multiply 100 molecules here, see 100 molecules, you can multiply 100 molecules, right? Say for example, this cup contains, okay, 100 molecules of nitrogen, 100 molecules of hydrogen, 300 molecules, right? Then only it will be correct. So until this 100 molecules of nitrogen, until this, then fully it is 300 molecules of hydrogen. Okay. So it produces totally 200 molecules of ammonia. Okay, so like that we can take, but we must understand what is it, Avogadro's number. Like this, we can multiply each and every molecule by Avogadro number also. Okay, so Avogadro, he was a scientist. Okay, so I will explain you. See, Avogadro, he was a scientist. He only proposed this idea in 1811. Okay, so that is equal volume of gases contain equal number of molecules. So that is his law. What is his law?
Equal number of gases.
Equal volumes.
Oh, equal volumes of.
Better write it. Equal volumes of gases contain equal number of molecules. Clear? So this is called, I can say it is called Avogadro law. Avogadro law. Okay. So equal volume of gases contains equal number of molecules. So that is his law. See, actually speaking, the actual value was determined by the scientist Perrin. His name was Perrin. Okay. Jean-Baptiste Perrin. His name is Jean-Baptiste Perrin. Okay, he only experimentally calculate this number and named it in honor of Avogadro, because Avogadro, only the reason he proposed the idea. So that he named it in honor of Avogadro. Okay. So how did they find it? So multiple experiment methods, not just one. Okay. So there are so many experimental method, Brownian motion. So this and all you are going to learn in your higher classes. So this is nothing but what is the Brownian motion? You know, tiny particles suspended in liquid move randomly, right? If you look at it, all the tiny particles, how you can see. Suppose if you see through the microscope, you can able to see it very clearly, even atomic level, right? So tiny particles suspended in liquid, right? It moves randomly, like this. This particle moves like this, randomly, zigzag motion. The zigzag. So it is Brownian motion, like. Okay. So by studying this motion, so we can say zigzag as a Brownian motion. Okay. By studying this motion mathematically, Perrin could estimate number of molecules in a given volume. Okay, and then he calculated the Avogadro's number. But it consists of so many mathematical formula and calculations that you will learn in your higher classes. What is Brownian motion and everything. So what is the formula included in it? So no need of worrying about all these stuffs in this lower classes, in this little class. Okay. Then this is first Brownian motion, it was done. Then electrolysis method also people are using, actually electrolysis. Electrolysis method means, you know, passing electricity through a solution. Okay, it breaks the substances. Okay, and then Faraday's laws of electrolysis also scientists used by measuring the charge required to deposit 1 mole of substance. How much charge is required to deposit 1 mole of substance? Like that, they have calculated number of particles. How many number of particles are involved in it? Okay, and then third one, the X-ray crystallography, we can say. So what is that X-ray crystallography? That is crystals. You know, crystal means there are two types of solids. One is amorphous solid, another one is crystal solid. Amorphous solid has random arrangement of atoms. Crystal solid has the regular, periodic, repetitive arrangement of atoms.
Solid can change its
Yeah, atomic arrangements are randomly changed.
change its state, room temperature too, right?
Yeah, exactly.
Oh.
Exactly. So, but the crystalline solids, it has the regular, periodic, repetitive manner of arrangement. So it is, yeah, very great. So NaCl is a basic crystal that are found in all kitchen, right? Okay. So scientists studied crystal structures using X-ray. So this is X-ray crystallography. Then they count number of atoms in a crystal. It's regular periodic arrangement of atoms. Like, so all these methods.
How would they count the number of atoms in the crystal?
That's what there is lot of lattice space.
Oh, wow.
It is involved, and then it is known as solid state physics. Yeah. So it is a very vast field. By using this, they have constructed a primary crystal. Okay, by taking one atom at a corner,
Oh,
corner atoms like that, then body center, face center, then HCP. So many things are there. Okay, when you look at it, so it will take, days to go to understand.
yeah.
Okay, that and all I will explain you in your higher classes. So right now, you can simply know by all these three methods. Okay, this is the later method. By all these three methods, the scientists found, try to calculate the number. Okay, all methods. See, this is the very great result by means of Brownian motion, by means of electrolysis method, by means of X-ray crystallography, all methods gave same value, 6.022 into 10 to the power of 23 number of atoms in a given volume. So it is Avogadro constant.
So they made this method in the honor of Avogadro.
Yeah,
And,
yeah, exactly.
okay.
Okay, so I can simply tell scientists didn't count atoms one by one. Okay, they used clever experiments and math to estimate this huge number. It is huge, right? Absolutely, it is huge. This number of atoms we can say, or particles we can say, right? 6 times 10 power 23 number of atoms, or 10 power 23 number of particles, right? Clear? Can you able to understand? So now also there is lot of methods, lot of probability, mathematical methods. Okay, permutation, combination, probability, so many things. Right now we are having to count the number of people in a stadium without counting individually. Okay, so there are so many methods, so many math involved in it. Okay, so this is an interesting fact. Okay, about the Avogadro number. Can you able to understand now? So right now we'll get into the syllabus. Now you know what is Avogadro number and what is the value of the Avogadro number, right? And then you must agree with this. It is the number of atoms, okay, in one standard volume, okay. So like 100 molecules, I said, right, in this cup there might be 100 molecules, but I had to say in this cup there will be 6.022 into 10 to the power of 23 number of atoms of each one. So nitrogen, one molecule of nitrogen, it contains 6.022 into 10 to the power of 23 number of molecules. Then it will be the mole.
Okay.
It will be the 1 mole of nitrogen. Then 3 molecule of hydrogen, which contains 6.022 into 10 to the power of 23 number of atoms. Then I can able to say 3 moles of hydrogen.
Okay.
Got it? So likewise, ammonia has, okay, so 2 into 6.022 into 10 to the power of 23 number of molecules. So it is 2 moles of ammonia. Can you able to understand? So how it comes, moles, okay? Then taking molar mass into consideration. So we will write like this. What is nitrogen? Nitrogen consists of, what is nitrogen? Nitrogen is 7 and 14, right? This is mass number.
Yeah.
So mass number, I've already told about, I've already insisted to my students, like always, mass number is very heavy, right? Since this 7, it is accountable for number of electrons. Number of electrons mass is 2000 times smaller than the protons, right? Proton is as heavy, 2000 times very heavy when compared to electron. So proton has mass, right? So, and also the neutron has the same mass as that of the proton. So if both combined, then you may understand in nitrogen, there are 7 number of electron, okay? Number of electron 7 and 7 number of proton and 7 number of neutron, right? Because if you add number of proton and number of neutron, this will be the nucleon number, mass number.
Okay.
Mass number, or I can say nucleon number, or I can say it is designated by letter A. A is 14. 7 plus 7, that is 14. That is number of proton plus number of neutron. Got it? That is equal to 14. What is this? This is actually atomic number. It is designated by a letter Z. Okay? Mass number is A. Atomic number is Z. So don't misinterpret for A, not like that. Mass number is A. Okay? So what is the mass number of nitrogen now? 14. Got it? So 14 times 2.
That's
Why it is 2?
because there's two number of nitrogen
Atoms. Because nitrogen is always diatomic.
Yeah.
So we have to represent nitrogen as a molecule always. It won't stay in a single atom.
Oh.
So it is diatomic. So N2 will be 2 into 14. So that is 28. Got it? Now we are converting molar mass. We are considering the molar mass. Okay? So 1 mole into 28 gram of nitrogen. Then for hydrogen, we can take 3 moles of hydrogen. Hydrogen, you know what is the mass number? Only 1.
Yeah.
So hydrogen also diatomic. So 2, right? So 2 into 3. 3 moles of hydrogen. So 2 into 3 will be 6 gram of hydrogen.
Oh.
So I can say 28 gram of nitrogen and 6 gram of hydrogen.
Okay.
It can produce 2 moles of ammonia. How can I calculate for ammonia? See, for example, here.
Ammonia for nitrogen?
So if you want, you can take a screenshot, then we'll move on to the ammonia.
Okay. For ammonia, you just have to take the mass of the elements.
Yeah, mass number of the total atoms.
Yeah, so
elements.
So ammonia is NH3.
NH3.
So if you combine 1 mole of nitrogen, 3 moles of hydrogen, that's 2 moles of ammonia.
Yeah, 4
So,
plus
yeah.
4 plus 3, right? Mass number of nitrogen is 14. Sorry, not 4, 14. And mass number of H3 is 3, right? H is 1. For 3 hydrogen, so it is 3. So 14 plus 3 is 17. There are 2 moles of ammonia. So 2 into 17. So 34 gram of ammonia.
Okay.
Can you able to understand this? Got it? So it is also tallied, right? What is 28 plus 6?
That's 34.
Yeah. So it should be tallied. So calculative. So always it should obey under the mathematical calculations also. Got it. So chemistry is not a joke. It is under the rule. Okay. And then let us write the equation in terms of molecule, in terms of mole, in terms of molar mass. Got it? This is the way the quantity of substance consumed or produced, right? Okay. So only if it is balanced, then only it is meaningful. Otherwise, it won't.
Okay.
Then we'll see volumetric relationship for reactions involving gases. Gay-Lussac, so he was a famous chemist. He found that the volume of the reactants and the products in gaseous state are related to each other by small integer, provided the volumes are measured at the same temperature and pressure. See, for example, it is Gay-Lussac's law. Don't misinterpret this Gay. Okay. So discovery of integer ratio in volume relationship is called actually the law of definite proportion by volume. Okay. What is this definite proportion by volume? Law of definite proportion. So it is given in atoms and molecules also. You can go through it. So I will post that video also. Okay. Then, for example, you are taking 2H2. You can consider instead of mole, you can consider volume also.
Okay.
2 volume and 1 volume like this. Okay. That is equal to 2 volumes of water molecule. And then volume can be considered as mole also, according to Avogadro's law. So hydrogen, oxygen, and water vapors are at the same temperature and pressure, say 100 degrees Celsius. Okay. And 1 atmospheric pressure.
Okay.
Okay. So same temperature and pressure, everything is in. Okay. See, from this basic concept, we can conclude that we take 100 ml of hydrogen.
Okay.
That is 2 volumes, right?
Yeah.
Then what will be the 1 volume? If you take 100
50.
ml, 50 ml. Then what will be the 2 volumes here?
100.
100 ml of water vapor. Okay, it is gaseous state. And measured at the same temperature and pressure. That's from a balanced chemical equation. We get relationship between mole, mass, and volume of the reactants and products. So don't worry and don't consider this as a big Himalayan thing. It is the relationship. You can consider molecule as mole, mole as molar mass. Okay, not mole as molar mass, mole as volume also. Molar mass you have to calculate from the number of things. Mass number, right? Molar mass has to be calculated from the mass.
Volume as well.
Yeah, correct. Can you able to understand this?
Yeah.
Okay. So it is very, very important, concept. Okay. And then you have to understand what is this. Okay. And let me know. I will let you know about all these stuffs. Okay. So number of moles, mass and molar mass, everything you know about it, right? Volume and everything. Okay. Then we'll see types of chemical reactions. Already I told you combination reaction, right? So what is the combination reaction? We have studied about all these stuffs, right? So two reactants to form a product. So it is the magnesium ribbon burns, right, with dazzling light. It produces a white ash, right?
Yeah.
So that every activities we saw in the first video, I have posted everything. So it is also the carbon, burning of carbon, right?
Yeah.
So carbon solid with oxygen. So combustion means it is mixed up with oxygen and then it gives CO2 gas. Okay. So like this, you can take all these reactions we have studied already, right?
Yeah.
So you just go through it. This is the reaction for combination. It is the first type, combination reaction.
Oh.
Okay. And then this also I've explained you from the activity, right? So you just go through it. And then you know about the exothermic reactions, right? These are all the exothermic reactions, okay? Then burning of natural gas also we saw. Got it? And then this glucose is breaking down into energy, respiration reaction. The respiration and digestion both are exothermic process. This is all we saw, right? Okay. Then I said decomposition of vegetable matter or biomass also like to compost, right? So everything is in that first video. You can go through it. Then decomposition reaction we saw, right? One reactant into two or more products. Okay. That also you know, right? Say this example, this also we saw. Do you remember that?
Yeah.
FeSO4 7H2O. If it is subjected under heat, it may lose water.
Yeah, if the heat is in the reactant side, it's exothermic.
Yeah.
If the heat is in the
reactant side means endothermic. And
the
product side means exothermic. Okay. So it produces FeSO4 solid and it loses water in the form of gas, vapor, water vapor. It went fully dehydrated. Then it is a solid right now. Ferrous sulfate under heat, always under heat, it converted into ferric oxide, sulfur dioxide, and sulfur trioxide. So this and all I have explained you, right? So go through it. Then lead nitrate, which is producing lead oxide, right? This also we saw, right? It is the yellow precipitate, decomposed, right? Precipitate gas. We saw that. So go through all these things. Okay, so I taught you already. Displacement reaction also I taught you, right? So this is, for example, iron solid with copper sulfate aqueous. What is meant by aqueous?
It can either change into a liquid or
Yeah.
a gas.
No,
No, it can
converted into ions. SO4 2 minus. Okay, always it may be converted into ion. So it is aqueous. Okay, it may be converted into Cu2 plus and SO4 2 minus. Okay, then it is FeSO4. See here also like that, Fe2 plus SO4 2 minus.
Yeah.
Okay, so it is now what is happening? Ferrous to the ferrous sulfate is added. It is displaced right now from copper. It is displaced to ferrous.
Displacement.
Okay, it is displacement, right? Like that zinc and copper sulfate. This we saw, right? Like that, this is lead, right? Plumbum. Lead and copper chloride. So plumbum chloride or lead chloride and copper is there.
Mm.
Double displacement means it is displaced like a swap, as you said. Okay. So it is the sodium sulfate and barium chloride. Now the sulfate and chloride swap together.
Mm.
Okay, so barium sulfate and sodium chloride. Got it? Make sure the equation has to be balanced.
Oh.
Okay, these are all the beakers. In the beaker, it will be all these things are performed. Okay. So exchange of ions between the reactants. So this is what it is happening. I told you, no? It is an aqueous, right? What is an aqueous?
Yeah, basically we're
Pa2 plus. It is converted into an ions.
yeah.
Clear? And also make sure you have to learn all the precipitate colors also. Sometimes it is very important for you. So white precipitate of barium sulfate. Okay.
Okay.
Is it clear for you? So reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Okay. So you see this Ba2 plus and SO4 2 minus, and then Na plus Cl minus. There is an exchange, two molecules, right? So it is exchanged and then it is producing the result like this.
Okay.
Can you able to understand this? Then this is very important reaction. This is the very first time you are going to learn about both oxidation and reduction. Okay. What is an oxidation? Addition of oxygen. So that is an oxidation. Can you write now? Oxidation means addition of oxygen. And also removal of hydrogen. That is also oxidation. See here, copper powder becomes black. Copper is usually brown in color.
Yeah.
When it combines with oxygen, then it is black. That means it is in the heat.
Yeah, that's true.
Okay. So if the heat is there, it is endothermic. Then what will happen? It becomes black color after heating. Okay. So this is the famous example for oxidation. Okay. See, if you cut some vegetables like eggplant, if you cut the eggplant, then if you keep that eggplant aside, then definitely you can see the eggplant is oxidized, like apple also, right? It becomes like color changes into dark. You have noticed that, right? Black color. So brown or black, for example, I'm saying it is also an oxidation, addition of oxygen. Okay. Okay, then again it is black plus hydrogen gas, it becomes again copper. Okay, plus water. Okay, copper oxides loses oxygen. Copper oxides loses oxygen and it is said to be reduced. If it loses oxygen, it is reduction.
Oh.
What is reduction? Reduction means removal of oxygen.
Okay.
And addition of hydrogen.
Oh, okay. So this is the
So vice versa. Yeah. This is oxidation reaction. This is reduction reaction. Can you able to understand? If both are combined, then it might be reversible.
Yeah, that's true because it's not chemical.
Yeah.
It's physical.
So it is redox, both combined in one reaction. That is redox reaction. So one reactant gets oxidized while the other gets reduced. See, this is the one reactant. It gets oxidized.
Okay.
Then it gets reduced, right? The other gets reduced to copper.
Yeah.
Can you able to understand? This is redox reaction. Is it clear for you? Can you able to understand this? So when a substance gains oxygen during a reaction, it is said to be oxidized. When a substance loses oxygen during a reaction, it is said to be reduced, right?
Okay.
But you can write both the thing. Removal of oxygen,
I know.
addition of hydrogen is reduction. Can you able to understand? This is reduction.
Yeah.
This is oxidation. Clear or not?
Mm.
Okay. Some of the examples are given. Zinc oxide plus carbon.
Mm.
It gives zinc sulfate plus carbon monoxide. Here we can say zinc oxide to zinc. What type of reaction it is?
That's oxidation reaction.
What is meant by oxidation?
It's where the oxygen does. Oh, here oxygen is removed.
Yeah. Then
So
what type of
it reduction?
reduction? Reduction, not redox.
Sorry, reduction.
Reduction. Okay. What about here?
Yeah, here also the same reduction.
Okay. Carbon to carbon monoxide.
Oh, okay. Then yeah, then it's oxidation.
Clear or not?
Mm.
So both in one reaction.
Yeah.
So this is redox.
Mm.
Clear?
Okay.
Can you able to understand this?
Mm.
Now tell me, MnO2, here it says
Mm.
MnO2 to MnCl2. What is happening here?
Mn is getting switched place. O2 is getting switched place by CO2.
That
So
means,
basically O2 is getting.
yeah,
So that means it's oxidation reaction.
oxidation or where?
Reduction.
So
Yeah, okay.
oxygen is removed, right?
Removed.
Removal of oxygen means reduction.
Yeah.
Keep this in your mind always. If oxygen is removed, then that is reduction. If oxygen is added, then that is
Okay.
oxidation.
Okay.
Then what is happening here?
So basically, 4H or hydrogen is getting replaced by, no,
4HCl.
4H
Now it becomes 2H2O.
and 2H2O.
That is chlorine is
Yeah, chlorine is getting
replaced by oxygen. Then what is happening here?
So basically, it's a reduction reaction. No, oxidation reaction.
Oxidation.
Sorry.
So both are there, right?
Mm.
Oxidation.
Yeah, oxygen is removed.
Oxygen is added.
I know that's not. It's not removed. It's added.
Addition of oxygen is here.
Mm.
Can you able to understand?
Yeah.
Here, removal of oxygen.
Mm.
These are all the example for what?
Mm. For redox reaction.
Yeah. There are one more thing also.
Mm.
Okay. So in all redox reactions, you can see one species is oxidized, another species is reduced.
Mm.
Okay. There is no oxidation without reduction.
Mm.
There is no reduction without oxidation.
Mm.
Okay. That means as this aspect of redox reaction will be explained broadly in terms of electron gain and electron loss. That also be there. Okay. So what is meant by oxidation? Okay. So oxidation means, see, you have already seen oxidation means in terms of gain of electron. Sorry, gain of oxygen. You can use these words addition or gain, right? Of oxygen. This is oxidation, right? And loss of oxygen or removal of oxygen.
That's a reduction.
Removal or loss of oxygen is reduction, right? Okay. See, let us consider this equation. This is also very important. Copper solid plus iron solid. That means it won't be converted into an ion. Solid means.
Yeah.
Iodine solid. It gives cupric iodide. So it is also solid. In the presence of heat, all are endothermic. Same way ferrous sulfide also. Same way cupric iodide also. Again, okay. Here, what is happening? Okay. These reactions do not involve any gain or loss of oxygen. Can you see any gain or loss of oxygen or hydrogen here?
No. There's
Okay,
no,
but yet these reactions are known as oxidation reduction reaction. This is redox.
Oh.
How can we able to understand? Okay, what is happening here?
Well, just because look, I have a question. So can it still be considered oxidation and reduction reaction even though oxygen and hydrogen isn't there?
Yeah, that's what we are going to see about the electron transfer. Okay, ionic compounds, you know, right? Like the same, all are metals. You can see copper atom is a metal.
Yeah.
It has the ability to lose 2 electrons. You know, 29 number of electrons are there. It is the atomic number for copper, right? It has 4s2. It is the outermost. Valency is 2. Right? So it can lose this 2 electron.
Mm.
It has the ability to lose this 2 electron. And then it will become copper 2 plus. Right? Can you able to understand this? Since the copper has the ability naturally to lose electron, it is known as it is losing an electron.